Have you ever felt that you're hitting a natural ceiling in your strength gains or wondered why muscle seems to vanish so easily as we age? What if I told you there's a master switch, a biological handbrake inside your own cells that is holding you back? This isn't science fiction. This is the cutting edge of biomedical research focused on a protein called myostatin. Let's get started. Welcome back, team, to the Building Lifelong Athletes podcast. Thanks so much for stopping by. I really appreciate it. If we haven't had the chance to meet yet, my name is Jordan Rennicke, and I'm a dual board certified physician in family and sports medicine. And the goal of this podcast is to keep you active and healthy for life through actionable evidence-informed education. Today, we're diving into a topic that's super exciting. A lot of people are talking about it. It's about muscle growth and muscle physiology and myostatin inhibitors. So what are these potential medications and how they might be helpful for us? So let's dive in. All right, so what exactly is myostatin, right? I said it's kind of the handbrake for muscle growth. Well, myostatin is known as growth differentiation factor 8 or GDF8. We're going to call it myostatin because it's way easier, but it's a protein that's in our own body and it's encoded by a specific gene called the MSTN gene. And the main job that it's really good at is to act as a negative regulator of muscle growth. So when I say negative regulator, what I'm saying is that it inhibits your muscle growth. So it's kind of the one being the limiter for that. So we know that we have this exclusively from when we're born, right? We have it all throughout our life. It's there, myostatin is there, and make sure our muscles don't get too big. And you might be like, well, Jordan, that sounds like a terrible plan. Why would I want that? I want as big muscles as possible. Well, you really don't, right? If you get too big, then you cannot function. You'll have to do other things that are very, might not be ideal for you. So there's a reason it's there and it throttles us, but that's typically what it does. And it's a part of a large family of proteins called essentially TGF, so transforming growth factor beta. So TGF beta, really big. We hear about all the time. Medicine has lots to do with immune function and lots of other things as well. So it's not like it's just a one thing, but it's involved with those people and it has a lot of different functions. So very, very important throughout the body. And how does it actually work though? So let's talk about it. It's actually a very precise molecular process, like most things are. Our body is finely tuned. It's amazing that it works in the way it does. But what happens essentially here is once myostatin is active in the body, it circulates around looking for a specific binding site on the surface of our muscle cells. So predominantly myostatin is almost exclusively in our skeletal muscle cells. I say almost exclusively because it's not 100%, but almost exclusively in skeletal muscle cells. They look for this specific binding site, and this is called the activin type 2B receptors or activin receptors. Essentially, there's activin type 2B, type 2A, activin 2, if we just know that, that's probably going to be good enough, but no, there's multiple types of that. And when myostatin binds to this receptor, it kicks off a chain reaction inside the cells, something through the SMAD pathway is what it's called. So SMAD, not important at all, but just for completeness. So this signal then travels into the nucleus where the essentially cell tells the body, hey, okay, let's put the brakes on things. So they're doing that. And so the results are twofold from this, right? So first, it stops precursor cells called myoblasts from multiplying and maturing into new muscle fibers. And then secondly, you get your existing muscle. It kind of actually puts the brakes on that. The key pathway for building, which is essentially this mTOR pathway. So most people hear about this mTOR when you put on, you taking protein or you do resistance training, it activates this mTOR pathway. That's what we're talking about here. It's kind of putting the brakes on that. And so it also, though, at the same time, can actually speed up the breakdown of existing muscle, primarily by turning on enzymes that tag them for disposal. So overall, essentially what they're doing is they're slowing things down. They're saying, hey, we're not going to build as much and we're going to actually slow down the process of building it and we might break down a little more. So obviously this is in flux though, right? This is not just like, oh no, like it's just happening all the time and I'm wasting away. That's not what's happening. You're building muscle, you're bringing it down, like your body's metabolically active. There's a nice homeostasis going on there, but myostatin is responsible for kind of keeping that in check. And what happens though when this is altered? And so this is what we're going to talk about here. If you're watching the video version, I have a picture of an enormous cow here that is muscle. We'll talk about that in a second. But the most compelling evidence for what got people thinking is and its potential power comes from nature itself. So we've seen this. There's some fascinating examples where natural mutations turn into to kind of spectacles. So essentially when there's natural mutations that turn off or turn down the myostatin signals, we see some certain things. You may have seen pictures of the Belgian blue cattle, which is pictured here. And this is essentially a doubled muscle look. So this is a direct result of a natural mutation in the myostatin gene, leading to a massive increase in muscle fibers in size. And if you look at the bull here, it is a absolute unit, just absolutely yoked. And so people are like, oh, what's going on there? Could that be the reason as to why, like we're having all this muscle? It's a myostatin. They're figuring it out. Interesting. We also had some additional things. We had these dogs called bullywhip. It's a type of dog, like I mentioned, and they had a mutation in their myostatin gene that gives them significantly more muscle. But what's kind of interesting as well is that here are these dogs. They kind of had a couple different ones. One could have one copy that's mutated. The other are both. And the dogs that had one copy mutated, meaning they had more muscle but weren't like enormous, they were better racers. So racing dog, there was kind of like a sweet spot. Whereas the dogs who had two copies had the huge look, like they were, yoked up, but they actually were like less athletic, didn't run as fast, and had issues like muscle cramping. So it wasn't all perfect. And actually, this mutation can happen in humans as well. It's incredibly rare, but some people are born with mutations that dramatically reduce their myostatin. And these individuals have up to twice the normal amount of muscle mass. They have increased strength, they have lower body fat, and they're just absolutely yoked just walking around. But the big thing is they don't seem to have a ton of negative health effects. And so that's where people are like, okay, those bully whippets maybe wasn't as ideal, but in the human versions, we've seen not necessarily huge negative health effects. So this is kind of like this proof of concept from nature, like, okay, maybe this actually will work. And so why are we talking about this now? Well, we're going to shift some gears here and talk about its more modern application, right? Not just necessarily for getting huge. We'll talk about that later, but obesity. That's the thing we're going to talk about. We're in the middle of a revolution right now with new weight loss medications like semaglutide, maybe known as Ozempic or Wegovy, and tirzepatide, which are known as Mounjaro or Zepbound, and they're incredibly effective for weight loss. They work. They will shed off weight. But here's the major catch. A big portion of that weight that is lost, if you're not actively lifting and increasing your protein, you can lose a lot of it not being fat. So sometimes up to 40% is not fat, meaning 40% of the total volume of weight that you lose could be potentially lean tissue. And that's not ideal. And so when we talk about lean tissue, we look at things like, yes, muscle mass, but there are other things like water, glycogen, bone mass, other things. But at the end of the day, the goal is not to lose lean tissue. It's a really big problem if you lose lots of muscle. And so losing a metabolically active tissue like muscle can lower your metabolic rate. It's going to make it harder to keep the weight off long term. Also may lead to decreased strength, reduced physical function, and can even increase the risk of frailty, especially in older adults. And this has created a new challenge: how to improve the quality of weight loss when around these medications. That's a big thing I see. I counsel every single patient I've ever started in this saying, hey, if you weren't resistance training before, you need to do it now. You need to make sure your protein targets are there, and you need to have resistance training because it's very important for maintaining that muscle mass. As we've seen in studies, specifically semaglutide, even probably more than tirzepatide, you're going to lose a decent amount of lean mass, and we don't want that. And so where does this come in? Well, this is where pharmaceutical says, hey, big pharma's like, we got an opening here. That's where we're going to go. Big pharma comes in and says, hey, let's innovate this and run with it. And so we're going to talk specifically about Regeneron Pharmaceuticals, a study that they've had and kind of are planning. It made the news recently. That's why I want to talk about it. And yeah, they've kind of released some things and have some things on the pipeline. And that's why I want to talk about it. And so their goal and their hope is that with these weight loss medications, they can do it in a better way and improve the quality of that weight loss. So their strategy is a combination therapy. So the idea is to pair a GLP-1 drug like semaglutide in their studies they're looking at with an agent that blocks the myostatin pathway, either a myostatin inhibitor or that activin receptor inhibitor. So one of those two. And the key investigational drugs that they have are called tivogrumab, which blocks the myostatin, and then garetosmab, which blocks activin A. So, fantastic names. First things first, you're like, why are these names so complicated? Well, there's like a specific naming way you do it in medicine. That's just how it goes. But the ending mab means these are monoclonal antibodies. And just one thing to mention here is that currently right now, the only one, but vast majority of these are injection based. And so these will probably be an injection, just like GLP-1, but a combination. So that's the first things first, but very long names, but one blocks just myostatin, the other blocks those receptors. And by giving a semaglutide to drive weight loss and simultaneously giving a myostatin inhibitor to help kind of slow down the muscle loss, the hope is that they're going to let the body burn off more fat preferentially and then actively protect or maybe even build lean muscle. That's like the holy grail, right? If you can lose fat and gain muscle, that's like ideal. And so what did they find? Well, there's been some promising results, that's for sure, in non-human primate studies, aka monkeys, where the combo therapy led to more fat loss and significantly less muscle loss compared to semaglutide alone. And yeah, they're starting to move on to human trials. So the study specifically that I just want to mention here for the non-human primates looked at 4 main groups. So a control group, one with just semaglutide, one with semaglutide plus the myostatin inhibitor, and then one with the semaglutide and both the activin receptor inhibitor and the myostatin inhibitor. So 3 different medications there. And the control groups, and if you look on the screen here, I do actually have the chart here showing, and the control group lost a little bit of body fat, not really anything happened to muscle, but really not a whole lot going on there. If you move over to the right in blue, you'll see that is going to be our semaglutide alone. And our semaglutide group definitely lost a decent amount of fat, but also had a decent amount of lean mass loss as well. And then After that, we have the semaglutide group with the myostatin inhibitor, and this is where it gets interesting. We see more fat loss and barely any lean body loss. So if you see, there's pretty much no lean body loss here and a huge amount of fat loss. And then moving over to the big one, the holy grail is going to be all three combined, right? So semaglutide and the receptor inhibitor and myostatin inhibitor, and you see huge amount of fat loss and then actually an improvement in lean body composition. So potentially fat or lean muscle gaining. So huge amount of fat loss and muscle gain at the same time. That is like literally the holy grail of everything we've talked about. And so they're getting jacked about this, right? So based off of this and the results, they're launching a phase 2 study called the Courage trial. It's a randomized double blinded study. I'm going to see, hey, do these inhibitors have the same effect on people who have obesity in the real world? So we've kind of gone to the basic science and then the animal studies, and now we're going on to humans. And so still very early. There's many things that go to stage 3 trials that don't come to market, but is very interesting. And this trial will be also interesting. 26 weeks, they're going to get the medication, and they'll have 26 weeks of weight maintenance where they're just taking the medication to see if, hey, these medications might help with weight maintenance as well. And so lots to look forward to and study, but that's why everyone's getting super excited about right now. And what else could this mean for the future? Well, the potential for these drugs goes way beyond obesity, right? One of the most obvious targets is sarcopenia, or the progressive age-related loss of muscle mass and strength. And sarcopenia is normal for everybody, right? We're going to have some amount of muscle loss. But when it becomes pathologic, affecting day-to-day functions, that's when we really want to act. Obviously, ideally, we'd act before that even. I'm not going to say, oh, we just wait till then, but this is like this is how it's going to get improved by insurance, right? Is protecting it for patients with sarcopenia and whatnot. And then once that's approved, everyone uses it to prevent that. But anyways, that's just what we're looking for. But it is a huge contributor, sarcopenia, to frailty, to falls, to disability, to loss of independence in older adults. And it's a huge deal. And some evidence suggests that as we age, myostatin activity might actually increase, accelerating this muscle decline. And so our body's just fighting against us. It's the worst. Getting older is the worst. I always do say, though, getting older is a privilege, right? Getting older is a privilege, but how can we do so gracefully? And doesn't mean we have to go down without a fight, that's for sure. But so researchers are now actively testing myostatin inhibitors to see if they can help older adults build lean muscle and, more importantly, improve their strength and physical function. So there have been trials out there that have shown increases in muscle size, but it didn't necessarily translate to functional outcomes that matter. So meaning it didn't help with them getting up, moving around, living a life. That's really what we care about. If we just have outcomes of, oh, like it looks like muscle's bigger, but that muscle doesn't actually do anything for you, then that's not necessarily going to be helpful. And obviously that's a double-edged sword. You could say, oh, just more muscle is more metabolically active. That could be helpful for you. Regardless, they're not going to get that proved just saying, oh, it increases muscle without a clinical outcome. So that's kind of how we think about it in like the medical world. Whether that's right or wrong, that's just what it is. But also, on top of that, we talk about sarcopenia. Another major area of focus are genetic diseases like muscular dystrophies, where the body's muscle progressively degenerate. So the hope here is that by boosting muscle growth, we can help compensate for the underlying disease process. And the road's rocky here, though, as it's definitely served an important lesson. Several early myostatin inhibitors from major companies like Pfizer and Roche were discontinued for not getting what they needed. Specifically, Pfizer tried one and Roche tried one. They both failed to show a significant benefit in functional outcomes compared to placebo. Like I mentioned, that's usually what they look for, not just muscle growth. It's, hey, does this matter functionally, right? So if you are in a wheelchair bound and you have a little more muscle, but you still can't get up because you can't use muscles, like that's not necessarily clinically going to matter to you. And so that's what we're looking for here is clinical improvements. So just something to mention. And one thing that has been exciting, though, is spinal muscular atrophy, but the story doesn't end necessarily with muscular dystrophies. They're starting to use these for lots of things. They're looking at them, and they've kind of titrated them from that was kind of early on, and then on more SMA more recently, they've kind of evolved and led a more refined strategy. And a perfect example is a drug called apitegromab, which is so fun there. So it's a company called Scholar Rock. It's made for spinal muscular atrophy, which is a genetic disorder that causes muscle weakness and atrophy. And this medication has a clever targeting mechanism. Instead of just blocking the all-active myostatin, it specifically targets the inactive precursor forms of myostatin right before it gets in the muscle. And so preventing it from ever becoming active in the first place, which is kind of cool. And it may have some other effects that we don't know about. And what's cool is that specifically, this has definitely shown progress. There's been a phase 3 Sapphire trial, and the medication showed a statistically significant improvement and clinically meaningful improvement in motor function for patients with spinal muscular atrophy. And it's a huge deal, right? So it's the first muscle-targeted therapy to succeed in a phase 3 trial for SMA, offers hopes to these patients. And once again, I'm just talking about the tip of the iceberg here, right? This is going to be big, at least potentially. At least people are trying to, because it looks like it could be really big, but that's where we're going. I think it's also worth mentioning another key player in this that I've seen as I was kind of researching this was Eli Lilly. They have a drug, bimagrumab, very fun to say. And this is an interesting one because it doesn't just block myostatin, but rather it blocks the receptors. So those activin receptors, they have the 2A and 2B versions. And so there's multiple of them. They're blocking multiple receptors, which is interesting. And there has been a study on these in obese individuals, and the medication seemed to do very, very well. It decreased the average weight loss of 6.5%. So it's losing weight in and of itself. And we had 20.5% reduction in fat mass with a combined 3.6% increase in lean muscle mass. So once again, kind of the holy grail saying, hey, we're seeing fat loss and muscle gain, and that's really big. So just as medication by itself caused a simultaneous fat loss and muscle gain, it suggests that blocking this pathway might have direct effects on fat cells, not just on muscle potentially, which is kind of fascinating, right? So can we remove the GLP-1s altogether? Who knows? But it does make this compound very interesting and blurring the lines between a muscle drug and a powerful metabolic drug. And yeah, there's more tests that have to go with this. They also have trials in the pipeline of combining this medication with semaglutide, lots of things, more details to come. This is just, like I said, the tip of the iceberg. But it's impossible to talk about these without addressing the elephant in the room, right? You might be like, cool, medicine's cool. You're a nerd, Jordan. Tell me the important stuff. And everyone in the health, fitness, and sports world are talking about this, right? So the very thing that makes the myostatin inhibitors so promising for medicine, their ability to potentially stimulate muscle growth, also makes them incredibly alluring for athletes and bodybuilders, right? This is the biggest thing. If you look online, you'll see, I saw a video all about this with Renaissance Periodization targeted at bodybuilders saying, hey, this is going to be better than steroids. But for someone looking to maximize physique, this represents a huge possibility of smashing through their genetic potential, right? And because of this, though, the World Anti-Doping Agency, or WADA, already says this is legal. It says you can't use it. This is clearly doping. But yeah, that doesn't mean people won't use it, though, right? Just because it's illegal doesn't mean they won't, especially specifically for bodybuilding. They don't really care about that. They don't test necessarily. There's definitely tested and untested divisions. But yeah, this definitely opens up the floodgates for misuse potentially. And so the more effective something is, the more likely people are going to use it. And so if we have this here, we're going to use it from a pharmaceutical perspective. People are going to find a way to do it, off label and for muscle performance or for just aesthetics. And that's what we think about. But yeah, that's kind of interesting. We'll talk more about that as they come and as it goes and as they'll come out more and more. But this is definitely I've seen people saying this is better than steroids, right? Better than steroids. Time will tell. And the big thing, they're so early, we have no idea what the effects are. But they have real potential, is that you can get enormous muscle growth and none of those androgenization effects. So you think about normal steroids, right? Things like testosterone, HGH, all the different formulations they have of anabolic steroids, they typically lead to lots of side effects, specifically things like baldness, body hair. I will, on the record show, I'm just this natural. I'm just bald. I wish people mistook me for taking steroids. But regardless, you can have lots of those things. For females, you might have a deepened voice or things like that. There's lots of side effects you get, and that's kind of from taking excess testosterone. These could potentially have none of those things, but still have muscle growth, which is really kind of like the holy grail. And that's going to be really, really big. Once again, like most things though, we don't know the side effects of this. We do not know anything about that. And so we kind of have to think about it. And to use these drugs outside of medical supervision is definitely a potential ethical and safety problem. Like ethically, it's like, you're an adult, you can take what you want. I'm not saying you can't or can't do this, but it completely kind of changes the algorithm here, right? So first and foremost, if you're in a fair sport, it's like doping, you can't do that. And, I'm not here. Nobody's watching this usually who's probably a professional athlete. If that is, it's a whole different set of different equation there. But the big thing is the health risks, right? So this is where I kind of say, hey, this is my job as a physician to talk about this. So these drugs, we have no idea what they really do long-term, like not at all, not a single idea. Also, we have no idea what they do to healthy populations. We so far only studied in a very, very small amount of people who have obesity, and that's who the trials are going to be for. So we don't know what they're going to do long-term. And like I said, people in previous podcasts, I'll say that people will find a way to get this made, whether that's through the black market or whatnot. And then you have no idea about the purity, whether it's going to be safe for people. You don't know anything about that. And on top of that, we don't know necessarily if it will actually be helpful. I do think it's pretty obvious that if you increase muscle and you're a bodybuilder, like it's probably going to help you in your sport. Like that's pretty standard there. But if you're in another sport and you just gain muscle, like will it matter? Remember the dogs, right? The bully whippets. It's an extreme muscle growth actually made them less athletic and was not helpful. And it's just a lesson that chasing a maximal muscle growth could push your body past an optimal point, potentially leading to injuries if your muscles grow too fast for your tendons or other unforeseen health issues. That's really the big thing. So more muscles doesn't automatically mean better performance or anything like that. And yeah, we just have no idea if it's going to be safe long-term. That's the biggest thing. I always say I'm never going to be on the cutting edge. That's just not who I am. I'm just a very conservative person. And so I'm going to let it kind of sit back and see and let it go. But I am super, super excited for these potential options to have for patients, or even, us as we age or whatnot. I don't know. I'm very excited, but I'm definitely cautious. And it's everyone's world. It's their job to hype these up in the pharmaceutical world because, it's going to be the best. It's going to be the best, but who never ever really knows. And so kind of wrapping it up here, what are the key takeaways? Well, first, myostatin is in our body. It's a natural protein that kind of puts the brake on muscle growth. And we're learning to modulate it, and it's a huge scientific advancement. It's going to be huge. In obesity, we're seeing a critical shift away from just weight loss to quality of weight loss, aiming to preserve muscle as best we can, which is really a huge development. That's why they're really actively looking at these right now. And specifically, though, they're also looking for other things like wasting diseases, sarcopenia, muscular dystrophies, all those things. And we can have awesome new targets for these pathologies that we see. But the big thing that people are going to talk about is these are going to be used all the time for non-medical reasons. And as I mentioned before, lots of good reasons for it. And I don't want to get swept up in it because it's really early, but man, this could be absolutely game changing. And once again, I'm trying to keep it down, my expectations, because it's so early in this, but just looking at it, the GLP-1s have absolutely changed the game. Whether, whatever your opinion is on them, they have some hot topics and hot opinions on them. They've absolutely changed the game, and they are completely game changing how we think about obesity and all that. So completely there. And I view like this could be that coming just from what I preliminarily see. I don't like getting excited about things, and it could fall flat on its face in humans, and that's totally fine. And that's okay. It's all good. But seeing what it could do, it could be really, really big, could be huge. And yeah, that's what I'm really excited about, just to see and learn more. Obviously, they're not just magic bullets, right? The science is evolving. The success requires, precision, safety, all that to keep going. But I'm excited to see where it goes. And ultimately, the goal, though, is to hopefully just keep you active and healthy for life. That's really why I'm excited about these. If we can be, active later in life, that's phenomenal. But yeah, that's kind of where we're at. But that's going to be it for today. Thank you so much for stopping by. If you enjoyed this podcast, it would mean the world to me if you either share this with a friend, left a 5-star review on your podcast platform of choice, or subscribe on YouTube. That'd be wonderful. But now get off your phone, get outside, have a great rest of your day. We'll see you next time.